we're going to go back and do some stuff on 1B, but let's do these two at the top of 2A quick, because these are really review of what we were talking about last week. Number 1 says draw an arrow diagram, include labels, and then find the components. It says 60 meters at a bearing of north 45 degrees towards the east. I hesitate to say this because I'm going to do an example today that doesn't follow this rule, but our book says start off either the north or south and then go. So this would be off of north 45 degrees to the east. It really doesn't matter because it's 45, so this is also 45, right? So the angle off the positive x-axis is also 45, which is the angle that we want for every one we do off the positive x-axis. Then the length of this vector is 60 meters. So that's really our drawing. And then does anybody remember how we do components? Yes. Does this look familiar? I don't know if that's on your reference sheets. Might not be because you'll have done enough of them by the quiz that you shouldn't need it, but it's the length of the vector times the cosine and the length times the sine. And again, that comes from, just so we're clear, if we draw this little triangle, this would be opposite. So that's using sine to find the y. And this would be adjacent to this angle in here. So that would be using cosine to find x. But to make life faster, rather than writing it all out, we just do 60, which is the length, times the cosine of 45, and then 60 times the sine of 45. Now, when it says find the component form or find the horizontal and vertical components, component form generally needs a signed number, so what quadrant you're in. If it says find the horizontal and vertical components, you actually don't have to give the sign, but it will help us greatly when we start adding them. Cosine and sine of 45 are just square root of 2 over 2, but we can do decimals. So what mode does your calculator need to be in? Yeah, just degrees. It doesn't matter about function or parametric at this point because we're not graphing. Can anybody type that 60 cosine of 45? Should be the same number for sine. Okay, so 42.4 and 42.4, right? All right, then this one says 100 pounds of force at 60 degrees to the horizontal. Again, whenever they say to the horizontal, we go off the positive x-axis. So this would be 100 pounds of force acting at this angle. So some of it is vertical force and some of it is horizontal force, but we can find those by just doing 100 cosine 60 and 100 sine 60. Thinking this is 50. Did I get that right? And this is the decimal that I don't know. All right, does this sound familiar to everybody? Components? All right, so I'm going to go back to worksheet 1B. And we're going to talk a little bit about adding vectors. Now, the tip-to-tail or tail-to-tail method both use basically law of sines and cosines. If you took physics, you probably use these. We're going to focus on the component method, but I will show you one example today of one of these methods. All right, we very briefly started talking about this question at the end of class a week ago. So you don't have this, so just follow along closely, please. Engage your brain because this is important for the examples you are going to have to do. It says an airplane is flying with an airspeed of 310 knots at a heading of 050. You remember that this means off of due north going clockwise when they give us these kind of compass bearings. So the angle in here is 50. But when we do components, we always need off the positive x-axis. So what would this angle be? 40. So we have a 310 knot effort off of a 40-degree angle with the positive x-axis. So the components of the plane's vector are going to be like this. All right. Now the wind is more complicated because it says it's a 78 knot wind blowing from. This is going to mess us up if we're not careful. On the picture on the quiz, I give you, like I did here, some indication of what's going to happen. I actually think I did something like that. So the wind is blowing from this direction, so it's pushing through here. Now, the from 125 means this all the way around to here is 125. Okay, use a little geometry. Paying attention here? Yes.
Oh, no.
Okay, if that's 125, if we take off 90, this angle in here is 35. Everybody okay with that? I took off the 90 for the first quadrant. Now, if I go around here and do vertical angles, that's also 35. Okay, so I need off the positive x-axis, what is this angle? So that if I were to separate the wind off,
1.5.
yes, this is 35. So 180 minus 35 is 145 degrees off the positive x-axis. And it was a 78 knot wind. I don't really have room to label that in here, but 78 cosine of 145 and 78 sine of 145. All right, guys, what I need you to do is grab your calculator and add these two together. Close the parentheses here and here. But what is 310 cosine of 40 plus 78 cosine of 145? Anybody getting something? Are you in degrees? Anybody else not getting that number? Okay, can you do these two back here? Still not getting it?
No.
Okay, 310 sine of 40, close parenthesis, plus, that said 78 before I scribbled over the top of it with red. 78 sine of 145. 244, anybody? Okay, so this is what's called the resultant, which is what the plane is actually doing. On this picture, if we had drawn this to scale and this was 310 and this was 78, this would be much shorter, obviously. And so the plane is winding up going 173 over and 244 up, so it's up here somewhere, okay? Now, we'll talk more about how we figure that out in a second. To figure out the actual speed of the plane in knots, we need to figure out if I have this vector that's going 173.6 over and 244 up, how can I figure out the length of that right there, guys? Pythagorean theorem, okay? So we need to be really clear on that. To find the length when we have the xy coordinates, we just do Pythagorean theorem. So can you do that with those numbers? 173.6 squared plus 244 squared, and then square root that answer. Anybody get about almost 300, 299.5? Okay, that's how many knots the plane's resulting in. Now let's think about this. It was trying to fly 310, but the wind is blowing like crossways against it, so it slowed it down to almost 300. Does that make sense? Okay, reasonable? All right. Now the other thing they want is the direction of the plane relative to the ground. I would assume they want a bearing in here. So let's find this angle first. If I gave you this little triangle right down here, how could you find that angle? Yeah, can we just do second tangent opposite over adjacent? Inverse tangent of 244 over 173.6. I have 54.6. Anybody else? Okay. That's not the bearing. How could we find this bearing off of north if this angle in here is 54.6? How about just 90 minus that? Yeah. Because this is a 90, right? Yes, the angle off of north. So 90 minus that 54.6 is 35.4. Let's move this. So 35.4 degrees. However we want to say it. It's bearing off of north or east of north, or we put a 0 in front, that makes it a compass bearing. So it's off north, okay. All right, now I'm going to do it the way that a physics teacher might have done it. And I'm going to kind of go quickly through this, but it's a good review of law of sines and cosines. So hang with me here for a second. When you do it in physics, you still use this here, and this was 310 knots. The angle here, I don't remember. Does anybody remember? It was 40 degrees in there, or 50 degrees. Okay, so this was 40 degrees. Then this wind was 78 knots. You slide it so that it's parallel, but it's tip to tail out here. So the plane was trying to do this, but the wind was pushing it this way. Do you see that the two blue ones are parallel, guys? It's kind of like you're making a parallelogram here. Do you see it now? So this is 78 knots. Okay, if I were to put a horizontal line in here, does everybody see that this 40 would make a Z, alternate interior angles with that 40? Okay, and then this angle down below here was, is that the one we want? Actually it is, because if we extend this, this was 35 degrees down here, remember? So this is 35 degrees, this is 35 degrees. These are parallel, so these are corresponding angles. This is 35 degrees. I think, let me double check that. Parallel. Blue line is parallel to this line. Yes. Okay. So here's my question. This is 75. Everybody okay with that? So if I take that and I pull it out, I have a blue line, a red line, a green line, 75-degree angle, 78 knots, and 310. Does anybody remember how law of cosines works to find this? X squared equals, anybody? Law of cosines? A squared plus, that's not degrees, this was knots, by the way, I wrote that wrong. 310 squared minus 2 times 78 times 310 times the cosine of 75 degrees. Could I not make that fit any better than that? Really, Rhonda? Yep, now I've messed it up even worse. Okay, there's supposed to be a 78 back here. All right, typing, guys. Okay, remember law of cosines. Okay, 78 squared plus 310 squared minus 2 times 78 times 310 times the cosine of 78 degrees, 75 degrees. This is supposed to be the cosine of 75 right here. Our angle is 75. Looks like I wrote 78. All right, then what do we have to do? Get a really big number because we need to do what now? Square root. Okay, if we square root that number, we get basically 299.45. Does that number sound familiar to anybody? Okay, same thing. So we found the length of this, but we had to do law of cosines and it got a little messy. Now the other thing is we would need to find the angle off of north that's in here. So we'd need to do law of sines to find another angle first, like this one. So you'd say the sine of that question mark is across from the side that's 78 here, in the same way as maybe the sine of this all 75 degrees is across from 299.45. Do you remember how to do that? Cross multiply and divide. 78 sine of 75 divided by 299.45, and then you would do second sine to get the angle. And I got, this is 14.6 degrees. Okay, so how do I find that angle in there? Yeah, 90 minus 40 and 14.6. 90 minus 40 minus 14.6 is 35.4. Please tell me that's the number we got back here. 35.4 degrees. Okay, so there's two ways to do these. I'm going to stick with the component form because after teaching this for a million years, that's, I find, what students do the best at, okay? Even though it's not the same as you do in physics. So if you want to do law of sines and cosines, go for it. But I am going to suggest that you just do these, and you can draw it all on one, or you can draw two separate problems for the, in this case, helicopter and wind. All right, everybody with me? You have this one. A helicopter is moving 15 degrees north of east with a velocity of 52 kilometers per hour. So, see, this says north of east. Does that sound like you're supposed to start at east and go only 15 degrees towards the north? That's what it says, but our book kind of says you're supposed to always measure off north-south, but that's not what this says. Okay, 15 degrees to the north of east, and it's going 52 kilometers per hour. If a 30 kilometer per hour wind is blowing from a bearing of 250, all right, from and 250. If I measure off of north, because it says bearing, and it's a 3-digit number here off of north, 250 would take me around into that quadrant, yes? Okay, but the wind is blowing from there, so I always do this. Mr. Wind is blowing this way, so he's actually blowing it back this way because he's coming from that direction. All right, got to do a bunch of geometry here, and we may want to just go up and do this on a separate axis for the wind. If this is 250, this is what angle in here, guys? $180 plus 70, so this one's 20, right? Everybody good? 250 minus 180 would make a 70 on that side, or the rest of the way here would be a 20. Okay. what we want is off the positive x-axis. So what's this angle? Mine is not drawn well at all. Let me fix that. Yes, the angle off the positive x-axis that the wind is pushing here is a 20-degree angle. So to do, and it was a 30-kilometer-per-hour wind. So what are the component form of the helicopter? The helicopter is down here. So it's 52 cosine of 15 and 52 sine of 15. Okay, what are the components for the wind? Right here. Okay, 30 cosine of 20 and 30 sine of 20. All right, we're going to add those. Now they're both quadrant 1 angles. 52 cosine of 15, close parenthesis, plus 30 cosine of 20, close parenthesis. I got that the resultant has 78.4 for an x component. Anybody? Yep. Okay. And then same thing, but be careful you push in sine this time. 23.7, anybody? Okay, so the resultant is in here somewhere. When we add those together, this is what we're getting. How do we figure out the magnitude from the components? Do you remember? Yes, yes. We're going to do Pythagorean theorem to find the magnitude of what's happening, the speed that the helicopter is actually going. So 78.4 squared plus 23.7 squared, and then square root that resultant, and we get what? I got 81.9. Anybody? Okay, look at the picture here. It's hard to tell, but if the wind is pushing and the speed was 52, could it end up being 81? Let me explain it this way. If the wind was pushing exactly 30 kilometers an hour behind it at 52, you would add them together and get 82, right? But it's not quite behind it. It's off just a little bit, so it's 81.9. Almost behind it. All right, now we need the actual angle of something. So I'm going to use these two components here and do inverse tangent. It's always inverse tangent of y over x. So it's 23.7 over 78.4. Inverse tangent 23.7 divided by 78.4 is 16.8 degrees. That is the angle off the positive x-axis. All right, let me just draw this one more time. So it was going 15 degrees. The wind was behind at 20 degrees. That's a total of 20 off there, pushing it. The resultant was out here somewhere. And it should be a little bit in between those, which we got 16.8. So the wind is blowing it just a little bit off course. This angle is 16.8. Now it doesn't tell us what we have to answer as. So if we wanted to just say that, what is that measuring off of, that 16.8? Yeah, or we could say north of east. If we wanted a compass bearing, we'd have to go this way. So 90 minus 16.8 is 73.2. I will be very clear on the quiz what you're measuring off of, okay? And I drew the pictures for you to help you. All right, so that's the idea of adding two vectors. What we're going to do now is go back to, oh, just kidding, I keep going to the wrong one. Here we go. Back to worksheet 2. Anything we can get done the rest of the period on worksheet 2, you don't have to do for homework. Okay? So where would you like to start? And just try 3, or you want to do 4? Number 3 to start? Okay. It says Caroline walks 45 degrees north of west. Okay, again, they're telling us off of west, 45 degrees to the north. And she goes for 1,000 feet. And then she walks 200 feet due north. I'm just going to continue off the end of this. We can do them as separate components in a minute, but do you kind of see where she's going to wind up, guys? Well, let me make this a little more to scale. That's 1,000. 200 isn't very much more, right? But she goes 200 feet north. Where is she from her apartment? So her apartment was here from the origin. All right. If I took that little walk to the north off, it would just look like this, 200. Now, what's the angle off the positive x-axis for that one? 90. Okay, so you could do 200 cosine of 90, 200 sine of 90. Does anyone know what that's going to turn out? Well, you should be able to logic it.
0.
Yeah, isn't she just at 0, 200?
Yeah.
Okay. Because that's what she went. She went straight north, right? Over 0 and up 200. Okay. Back here to this problem, her first little jaunt, we want to get the sign right though. So we're going to use the x off the positive x. So that would be 135, 180 minus 45. Everybody okay? Or you can just do 1,000 cosine 45 and sine 45, but you're going to have to remember that it was to the left. So if we do 135, we have 1,000 cosine of 135 and 1,000 sine of 135, which gives me, anybody? 890 or something? I'm making that up. 707, negative 707.1 and positive 707.1. Anybody type both of those and double check me? We good? So if we add those together to see where she winds up, we get, add these two x, and we get negative 707.1. Add these two y, and we get 907.1. Look at the picture here, guys. Does that make sense that if she went to the left and up, she would be here? Hey, Vaughn, you lost? Need me to back up? Okay. So she walked 1,000 this way and then straight north. So the 1,000 this way was negative 707 to the left and positive 707 north. But then she walked 200 more straight north. So where she is now in comparison to the origin is 707 left and 907 north.
Oh,
Okay, back to the origin is here. So if we want to find out how far she is from her apartment, what can we do? Yes, we need to just do the Pythagorean theorem. Please be careful when you have a negative number and you square it, it becomes positive. So it's okay to either not type it in or to use parentheses if you're really going to worry about it. I would just type 707.1 squared plus 907.1 squared and square root it. Don't worry about it because you're going to square it anyway. $11.50, anybody? Or did I do something wrong? That we got about 1150? Just about 1,150 feet from her apartment. Now, it asks, what north of west bearing is Caroline from her apartment? Okay, north of west. So they want the angle in here, but I'm going to do what we're always going to do, is we're going to do inverse tangent of this, these two coordinates here, 907.1 and negative 707.1. Oh, this is going to be struggle, guys, because it's going to give us a quadrant 4 answer. Divided by negative 707.1. I'm going to get negative 52 degrees. Okay, that's because the calculator always, do you remember anything about those inverse functions? Remember the colored unit circle? Tangent is in quadrants 1 and 2 only. So the calculator thinks, or I'm sorry, 1 and 4. The calculator thinks you have to be in quadrant 4, 52 degrees. Obviously, she's not down here, right? What can we do to put that into the right quadrant? Instead of negative 52, well, you actually can, because I would add 180 to put it over here, but they want this angle anyway, off of west. Is that not the same because of vertical angles right there? So she's 52 degrees north of west. Okay, let me try to draw that better here. If we got an angle that was 52 degrees here, it would also be 52 degrees here. Everybody good? Vertical angles. And she's clearly further, if she's gone north further, she's got to be more than 45 degrees from west. All right, that was a little confusing. We're getting there. Just remember, always Pythagorean theorem and inverse tangent. You want to do one with wind? Let's try this number 5. An airplane is flying with an airspeed of 500 miles an hour at a heading of due north. Oh, well, that's easy. Let's just do the plane here. Anybody give me its components? Well, you could use 90, right?
Yeah.
But it's going to turn, so you could write 500 cosine of 90, 500 sine of 90. But it's going to turn out to be 0 to the left or right and 500 straight north, right? Then it says, if a 50-mile-an-hour wind is blowing at a bearing of 270, not from, okay? At means in the direction of a bearing of 270. So 270 off of north would be here. At a bearing of. So it's not coming from there, it's blowing that way. So it's actually blowing, okay, but it's very short vector. It's only 50 miles an hour. So you could do, what would that be off the positive x-axis, guys? Yes, so you could do 50 cosine of 180, 50 sine of 180. Anybody know what it's going to be though? What would get me out to the end of that vector? Left 50 and up 0. Same thing if you type it in, guys. Okay, determine the magnitude and direction of the plane relative to the ground. If we add those, what do we get? So where the plane is actually ending up is here, negative 50 and 500. So how do we find out its speed? Pythagorean theorem, okay, can you do that for me? Either leave the negative off or put parentheses around it. What'd you get? All right, I want you to think about whether that makes any sense. If I go over here and try to make these more to scale, this one is actually 10 times as long as this little green one, right? Because it's 500 and this one's only 50. Right. So the plane is mostly just going north, but it's being pushed a little bit towards the west, and its speed helped it a little bit, but not much, hardly at all, right? Because it's like a crosswind. It's acting totally at a 90-degree angle to it. All right, now we need to find some kind of an angle, and we need to decide if we're going to do a bearing. Yeah, let's go with a bearing because this question didn't have anything else. So if we do inverse tangent from our plane here, was it a plane? Yeah, 500 over negative 50. What do we get? It's going to be a wrong quadrant because it's got a negative number in it. I got negative 84.2. Anybody else? Okay, so it thinks we're down here, negative 84.2 degrees. That would then also be here, 84.2 degrees. So if we want a bearing, what could we add to 84.2 to make it off of north? 90, 90, 90, plus 84.2 all the way off of north. So add 270 to that, but we need a positive. 84.2 plus 270. Yep, 354.2. When you do a bearing, you're supposed to start off of north. If it's just a bearing, a true bearing off of north, you start at north and go around clockwise. You got to go all the way around. So, but does that make sense, everybody, that it would push it? The difference there is roughly 6 degrees, right? That it's pushing the plane just a little bit off here, 6 degrees. This is a bearing. On a test or quiz, one more time, I will give you a picture with some stuff drawn on it, and I will tell you what kind of an angle that you have to do at the end. All right, do we have time to do one more? What do you want to pick? What do you want? 6? Okay. 2 tractors are removing. 1 is pulling with a force. With the sum of the horizontal vectors, what is the sum of the vertical? Okay, so let's just figure out the components of one going this way and one going this way. To get the components of this one, we'd have 2,000 cosine of 20 degrees off the positive x-axis, yes? And 2,000 sine of 20. 2,000 cosine of 20, 2,000 sine of 20. I got 1879.4. Anybody? Did I type it right? And 684. Did anybody else get those numbers? Okay. What's different about this one? 2 things. This tractor is not pulling as strong on the stump, right? And what else? It's a different angle, so what are we going to do? What is that angle off the positive x-axis? We can't use 20. because it's pulling down. Can we just make it negative 20? Do you see what I'm saying, guys? If we do 20, it's going to wind up in the first quadrant too. You could use 340 if you wanted to go all the way around, but negative 20 will work. So for this tractor, we're doing 1500 cosine of negative 20 and 1500 sine of negative 20. 1500 cosine negative 20, 1500 sine of negative 20. I got 1409.5 and negative 513. Okay. What is the sum of the horizontal components? Okay. Horizontals which way? Cross or up and down? Cross. We're going to add these two. Can you add those two numbers? $1879.4. I got about 3289. Does that seem right? Anybody else get those? What's going to happen though when I add the vertical components? One was pulling up and one was pulling down, so they're going to undo each other greatly, right? 684 minus 513 or plus negative 513, 171 vertical. Or you could have just written 3289 and 171. Okay, what is the resulting force on the tree stump? Yes, Pythagorean theorem. $3293 roughly, 0.4 maybe. I'm rounding weirdly all along this, but okay. What would changing the angle of the tractors affect the magnitude of the resulting forces if the angle remains 40? If the angle stays 40, is the strength that they're pulling with going to change? No, the difference between what they're pulling at right now is 40, right? If this one had pulled this one 40 and this one at 0, the magnitude would still stay the same. It's just the tree trunk would fly in a different direction when it let loose. All right, guys, finish worksheet 2 and the book work. I don't know where that was. The beginning? Yeah, here it is.